Hi, Assalamualaikum. Our group will do nodal analysis, mesh analysis, Thevenin, and Norton theorem for this circuit. And the objective is to understand more about theory analysis and apply it to AC circuit and get same answer by using different theorem. Hi, my name is Mohd bin Hosni, and I'm doing nodal analysis. This is the circuit that we use to calculate voltage and current at R4. This table is simulation result and need to compare with calculation. This circuit also has 4 nodes. Each node need to apply KCL. For node 1, this is the equation. I represent equation 1. For node 2, this is the equation for node 2. I represent equation 2. For node 3, this is the equation. And lastly for node 4, this is the final equation. I represent equation 4. After you get 3 equations, then you need to solve it by using Cramer's rule. Firstly, you need to find the determinant. And the answer for determinant is 0.1532 plus 0.1052. For determinant V4, this is the matrices and this is the final answer. After that, determinant V4 is divided by determinant, then you get the V4. This is the value. In order to find voltage across R4, V4 is minus with voltage source 1, and this is the answer. In order to find current at R4, V4 is minus with voltage source 1 divided by 4 ohm. This is the final answer for current at R4.
Assalamualaikum. Now I will explain how to calculate using mesh analysis. This is our circuit. Before start calculation, change the inductor and capacitor to impedance value using the formula for inductor J omega L, for capacitor 1 over J omega C. Then assign loop into loop 1, loop 2, loop 3 and loop 4 with same direction, which is clockwise. Then use KVL to obtain simultaneous equation. For loop 1, I1 is equal to 10 angle 0. For loop 2, write the equation, then substitute I1 into loop 2 with 10 angle 0. For loop 3 and loop 4, also use KVL to get the equation. Next step, solve the simultaneous equation by using matrices. Calculate the determinant and determinant I3. To get I3, determinant I3 divide by determinant. I0 is opposite direction to I3, so I0 is equal to negative I3. The answer for I0 is equal to 4.006 angle 101.99 ampere. After got I0, calculate V0 using Ohm's law. I0 is equal to V0 over R, which is R equal to 4. Then the answer for V0 is equal to 16.026 angle 101.99 volt.
Hello, welcome to Circuit Theory. Today I'm going to tell you how to solve AC circuit theorem using Thevenin theorem. Now, first of all, this is our design of full AC circuit based on our group task. first step is we need to find the ZTH using the star delta formation, and thus we have the value of A, B, and C. From the value of A, B, and C, we can find the Rn, and from that we can find the ZTH using B parallel A plus C. Next, this is the information from the circuit that we have, and we will proceed by finding VTH using mesh analysis, as you can see from the circuit, to find loop 1, loop 2, and loop 3. And from the equation of loop 2 and loop 3, we can proceed by using matrices to find the current I2 and I3, and finding the determinant to find the value of I2 and I3. From the circuit, we can construct the circuit to find VTH using current divider rule, and then we can draw a Thevenin equivalent circuit, and to find the voltage we can use VDR and Ohm's law to find the I0 at R4. Thank you. That is all from me.
Hi, my name is FIRDAUS, and this is my part, which is Norton theorem. For Newton theorem, this is how I get my I4 and V4. This is its original circuit, and this is the first step. Step 1 is we have to label all the loop one by one, which is I1, I2, I3, and I4. Then we have to do a mesh analysis without the RL by applying KVL based on directions current, which is I1 is given, and 8j I2 plus 6 I2 minus I1, 0.5j I2 I4, 8 I2 I3 I4 plus 7.5j times I2 minus 6 I1, 0.5j I4 minus 83 equals 0. Then we have to expand this, and then lastly we will get this equation for 2. For equation 3 is loop 3, negative 20 plus V8 plus V5 equal to 0, and we expand it, which is 13I3 minus 8 minus 13I3 minus 8I2 minus 5I4, and equals to 20 angle negative 50. For loop 4 is 25 degree plus V, and equals to 0, and then V minus 0.5j equals 0.5j I4 minus I2. Then we will get this loop I4 loop equation. Then we have to step 3, we find the RTH, means that we remove the I4 source, and then we'll do star and delta analysis, and then after we get we simplify the circuit, which is B is parallel with A, B and A. Then we get this. Step 5, find the R4 by using Kirchhoff current divider rule, which is R4 equals Rn over Rn plus 4 times In. We're given here equals, and then after we get In, to get VRL is IRL times VR4, and this is how we get our answer. Thank you.